Okay, we're back. Lesson 4.1e. And this one starts on page 26. We've got 9 equations we need to solve. And these equations have rational numbers. So we're working with fractions and, in a couple of cases, decimals. They ask us to solve our equation algebraically, check our solution. We want to make sure we show all of our algebra steps. And just like we did in the previous lesson, we're going to be using opposites, we're going to be using reciprocals. The only difference is we have some fractions and decimals that will obviously slow us down a little bit. But we know how to work with fractions and decimals from Module 2, so here we go. For problem number 1, I notice it's subtraction, so I want to rewrite it as addition. So v plus negative 3/8, using my definition of subtraction, equals 1/8. So remember, the goal is to isolate my variable on one side. So I want to isolate v on the left side. And I can make that happen if I add the opposite of negative 3/8 to both sides. So I'm going to add positive 3/8 to both sides. And on the left side, negative 3/8 and positive 3/8 is 0. That leaves me with v on the left. Now on the right side, I have a common denominator. So 1/8 plus 3/8 will give me a denominator of 8. And if I add my numerators 1 and 3, I have 4. So v is equal to 4/8. Of course, that is not in simplest form, so I need to simplify, and v is equal to 1/2. So I have my solution, and now it's time to check and make sure that it in fact works. So just like always, I'm going to rewrite my original equation, v minus 3/8 equals 1/8. Now, instead of plugging in 1/2 for v, I'm going to plug in 4/8, because remember that 4/8 is the original solution we got. It just wasn't in simplest form. But by using 4/8 instead of 1/2, when I plug it in, I have common denominators already. So it's going to save me an extra step. So I want to be thinking about things like this. On the left side, I have a denominator of 8. And if I look at my numerators, 4 plus negative 3, that will give me a positive 1. So 1/8 equals 1/8, and we're good for number 1. All right, number 2. So I have 3/4 r is equal to 2/3, and I've rewritten it because we should never work off of the original equation. You might remember we had an equation like this on the previous worksheet. Rather than dividing both sides by 3/4, because that would look a little complicated, it would be better to use a reciprocal in this case. So I'm going to multiply both sides by the reciprocal of 3/4. The reciprocal of 3/4 would be 4/3, and I'm multiplying by 4/3 on both the left and right side to keep my equation in balance. Now on the left side, if I multiply, I would have 12/12, which is 1 whole, and 1 times r is r. On the right side, if I multiply straight across, 2 times 4 is 8, and don't forget to multiply the 3 times 3, which is 9. So I have 8/9, which is simplest form, and so we've solved it. That was quick. So as long as you know what to do on both sides, we can be pretty efficient. When I check this equation, I start with the original, 3/4 r equals 2/3. Now, unlike the last equation, I don't have a choice here. So I'm plugging in my answer, which is 8/9, and I want to make sure that 3/4 times 8/9 is in fact equal to 2/3. So I'm going to do a little cross reducing. 4 will go into itself 1 time, it goes into 8 2 times. 3 will go into itself 1 time, and it goes into 9 3 times. If I multiply on the left, 1 times 2 and 1 times 3, I get 2/3, and that's what it's supposed to equal, so we're happy about that. All right, on to number 3. For number 3, again, I'm going to rewrite this because it's not a good idea to work off of the original equation. We don't want to be lazy, only takes a couple of seconds. It's already addition, so no need to rewrite using the definition of subtraction like we did for number 1. I've just boxed my variable n as a reminder that I want to isolate that variable on the left-hand side. So I'm going to add the opposite of a third. The opposite of 1/3 is negative 1/3. I need to do that on the right side as well. So I'm adding negative 1/3 to both sides. On the left side, 1/3 and negative 1/3 give me 0. So n is all that remains. Now on the right-hand side, it's not quite as easy as number 1. Remember for number 1, we had common denominators already. For number 3, we do not. So in order to add 7/12 and negative 1/3, I have to have a common denominator. My common denominator for 12 and 3 would be 12. So if I look at the first fraction, I've multiplied by 1 to get 12. So that means that my numerator won't change. I still have 7/12. For my second fraction, I've multiplied 3 by 4 to get 12. And so 1 times 4 is 4. Of course, I need that negative sign. So negative 4/12. So now I can combine on the right-hand side. My denominator will be 12. And I'm going to have 7 plus negative 4, which is 3. So n equals 3/12, but like number 1, it's not in simplest form. I can simplify to 1/4. So for number 3, n equals 1/4, and now it's time to check and see if that in fact will work. My original equation was 1/3 plus n equals 7/12. And when I plug in my solution, it becomes 1/3 plus 1/4 equals 7/12. Now I can't fake anything and just say, oh yeah, 7/12 on the left equals 7/12 on the right. I really have to do the math and make sure that it is going to work. So to add 1/3 and 1/4, I need a common denominator again, which will be 12. And then notice that both denominators changed, so my numerators will as well. My first fraction I multiplied by 4. My second fraction I multiplied by 3. And so I'm going to have 4/12 plus 3/12, and that must equal 7/12. And of course, if we look at it, it will. So my denominator will be 12. 4 and 3 is 7. So 7/12 on the left equals 7/12 on the right. Running out of room here. Okay, so like I said, these equations are no different than the simpler ones that we solved in the previous lesson. The only thing is, working with fractions is slowing us down because of common denominators and stuff like that. All right, on to number 4. So for number 4, it's already addition, so I don't need to worry about rewriting as addition, but I do want to rewrite it because, again, we don't want to work off of our original equation. So x plus 1/2 equals 5. I'm going to isolate x on the left-hand side, and the way I'm going to do that is by adding a negative 1/2 to both sides. Now on the left side, positive 1/2 and negative 1/2 would be 0, so I have just x. On the right side, we can be logical about this. So if I have a positive 5 and I'm adding a negative 1/2, I'm going to have half of a 0 pair, and that's going to leave me with 4.5 remaining. So positive 5 and positive 1/2 would be 5.5, but I have positive 5 and negative 1/2. So I am essentially subtracting the 1/2, and that gives me 4.5. So I have my solution. That was pretty quick. And now let's plug that into the original to make sure that it works. My original equation, x plus 1/2 equals 5, comes first. In place of x, I have 4.5. And when I add 1/2 to it, I should have 5. And of course, 4 and 1/2 plus 1/2 does equal 5. So showing that the two sides are equal, good news, which means we can go on to number 5. So what I notice about number 5 is we have decimals instead of fractions this time. Okay, we can work with the decimals, I have 0.25x and plus -2 using the definition of subtraction equals 8. So my variable term is a decimal, and I want to isolate that first on the left-hand side. So if I add +2, -2 and +2 will be 0. Of course, I have to add that on the right side as well. So all that remains on the left is 0.25x, and on the other side I have a +10. So I have my choice here. I can divide both sides by 0.25, and that will tell me what x is equal to. Or I could use a reciprocal. So I could use a reciprocal, kind of awkward because I have a decimal. So my other choice would be to write 0.25 in fraction form, which is a fourth. So instead of 0.25x, I can represent it as 1/4 x. And now I can see that I have a fourth of x, and if I want the whole thing, I need to multiply by 4, because 4/4 will give us 1 whole. And of course, if I do that on the left-hand side, I must also do that on the right-hand side. In this case, 4 times a fourth is equal to 1 whole, and I have x. On the other side, 10 times 4 is 40. So we have our solution, x equals 40, and now it's time to check it. I have 0.25x minus 2 equals 8. I'm going to leave 0.25 in decimal form. X, of course, we replace with our solution, which is 40. And plus -2 equals 8. So I've used the definition of subtraction to rewrite as addition. Now, 0.25 times 40, I could do the multiplication off to the side. I can also think about 0.25 as a fraction, so I'm thinking of 1/4 of 40, and a fourth of 40 is 10, and 10 plus -2 will give me 8. So two sides, both equal 8, our solution is correct. All right, for the next one, I've got 8x is equal to -1/4, and I could divide both sides by 8 to figure out what 1x is equal to, but if I look at the other side, I have a fraction, so over 8 is going to look a little awkward. So I'm going to use a reciprocal again. Instead of dividing by 8, I can take 1/8 of each side, and in math, of means multiply. So 1/8 of 8 is 1/8 times 8. Of course, my 8s will simplify, leaving me with 1x or x. And on the other side, when I multiply, I don't need a common denominator. I multiply straight across. 1 times 1 is 1. 4 times 8 is 32. Of course, a negative times a positive is a negative. So x equals -1 over 32. Okay, now for my check. 8x equals -1/4, our original equation. I'm going to multiply 8 times my solution, which is -1 over 32. I have to make sure that that equals -1/4. Might be helpful if I put 8 over 1. And now for some cross reducing. 8 goes into itself 1 time, 8 goes into 32 4 times. I'm looking at my numerators. 1 times 1 is 1. My denominators, 1 times 4 is 4. Of course, I had a +8 times -1 over 32. So I have a negative product, and -1/4 equals -1/4. So 6 down, I believe we have 3 to go, and those next 3 will be covered in the next video. So I'll be right back.